Okay, here we have a short explanation video of how we can measure the percentage damping of trim materials. So our setup is a small electro-dynamic shaker with force gauge, some aluminium structure to support the sample, and then on top of the sample a small aluminium mass with an accelerometer fitted to the top of it. So as you can see, we set the shaker going with a sinusoidal input, sweeping from 50 Hz up to about 2.5 kHz. And over that range, we see that the mass and the accelerometer have their own modal behaviour, and we can pick out a frequency for that mode. It's quite hard to see at the moment on the video because the strobing effect, but here you can see we've slowed it down. You can see that motion a bit better. When we look at the response of the mass spring system with respect to the force input, we can see that it's quite a wide peak, and that's because it's acting both as a spring and as a damper. And we can use the half power bandwidth method to calculate that level of damping for each material sample we test. Looking at another example here where we're just using pure springs, and they are likely to have a lot lower damping, more just a stiffness effect. And as you can see again, we get good modal behaviour, clear modes of the mass and spring system. And when we look at the response between the force input and the vibration, we see a much sharper peak, much lower damping.